right, we can go ahead and get started. Before I welcome any of our guests, I'd just like to invite those who have not already done so. Please subscribe to our YouTube channel, Magnimind Academy. We upload recorded sessions of these talks so you can watch them later. And you can also comment any questions on YouTube in the comment section below or what you think about today's talk. Now I'd like to welcome Wes Barlow and his talk, Meta Skills for Data Scientists. We at Magnimind try and find different speakers who can deliver workshops like these filled with current information or maybe a different perspective to go along with our data science education programs. These programs range from focusing on just one or two fundamental skills all the way to helping an entire career change into the industry. And our goal at Magnimind is impacting as many careers as we can. This is just one way that we do so. Barlow joins us as the senior data scientist at USAA, where he has worked for the last 15 years. He is the technical lead for his team and supports them by developing psychometric instruments, designing and leading experiments, and building compliant models for understanding and predicting behaviors. He is also the president of a nonprofit in Medina County, Texas, that works to give more empowerment of STEAM education in his community. Graduating from Texas Tech, Barlow went on to get his master's in predictive analytics and doctorate in performance psychology. Before we begin the presentation, I'd like to introduce my superior, NSN, who will be giving a few words about upcoming opportunities with Magnimind.
Hello, everyone. Welcome to today's meetup. My name is Muhammad Sen, and I am Chief Operating Officer of Magnimind Academy. I'd like to talk about one of our upcoming programs in detail, our dual postgraduate and certificate program that we organized with Wisła University in Poland, Warsaw. During this bootcamp takes 16 weeks and a total of 200 hours. During the bootcamp, you will learn about data analytics, visualization, machine learning, deep learning, and AI seminars and interview practices. So as an outcome of the bootcamp, you will receive a diploma from Wisła University and a course completion certificate from Magnimind Academy. You will become a part of Wisła University and Magnimind network. And the schedule for the bootcamp, the application deadline will be on October 16th, and the bootcamp will start on October 17th. It will take 16 weeks, and you can check our website. Our team will share the necessary link to learn about program in details, and you can check the chat to learn more. Thanks for listening, and we can continue with our speech. Thank you.
And then we'll get started. So my one of my goals today with this talk is to one of it's to be done before the VP debate, so we can go over and see that, which I don't know. Hopefully, I don't know if I want it to be more or less exciting than the last debate, but here we go. So I will get started. So as I was introduced, so Wes Barlow. I'm in rural Texas. I live in the middle of Texas. I was remote working kind of before it was cool. Not quite as rural as the image behind me shows, but kind of out in the middle of nowhere, about an hour west of San Antonio. I have worked in the analytics space for 15 years, primarily at USAA, but have done some other things kind of outside. What I'm going to talk about today, meta skills, it's a little, I guess, unique in the data science space. I'm one of the few kind of psychologist data scientists. It doesn't seem, I don't meet a lot of other people that have kind of made that jump. So hopefully they start becoming more common. Let's go ahead and forward if I can get my slides to move. There we go. All right, so the overall format of this presentation will start more tactical, and as it goes gradually grow more strategic. That way, if your eyes start to kind of glaze over halfway through, at least you'll come away with something actionable. And also, if you don't have the fortitude to get to the end of this talk, then the odds of you being able to implement some of the strategies mentioned at the end decrease. So, there's that. We say it's by design. So things we're going to cover initially is we're going to talk about cognitive biases. I'm going to talk about imposter syndrome and Dunning-Kruger and kind of how they link together and how you can kind of spot and mitigate. And then finally, the last subject is really around optimal performance. let's jump in. So meta skills. So first, I think it's imperative that I kind of talk about what a meta skill is. So first order skills are those items that you should be used to learning about in data science talks. So you have foundations in stats or linear algebra or calculus coding, and you have all the wonderful algorithms that can be constructed to help explain problems. 10 years ago, it was all about neural nets and support vector machines and random forest. And now really just in the last, I don't know, year or so, I really see a lot on topological data analysis, which you'll be told is necessary if you want to be able to explain how your model is working. And a hint, if you ever plan to build a model for a company in a highly regulated industry, you'll need to be able to explain how and why it works. And all of those things are fun and great, and they're exciting to learn. And every few months, something new comes out, some new R package, or maybe some recent conversion of an R package in a Python, or maybe Elon's going to finally release Skynet. Those are all exciting, but unfortunately, this talk is not about those. This talk is focused on the more human side of things. So regardless of what your particular domain or selected methodology may be, today we're going to be discussing skills that can help you be a better data scientist. So whether your future involves building linear or logistic regression models that are still the easiest thing to get past the financial service regulators, or your future involves spinning up 10,000 GPUs to determine someone's likelihood to buy a product based on pupil dilation when they walked in the door, these meta skills we talk about here should kind of apply to you equally. So to kick off meta skills, we're going to talk about cognitive biases. While this talk will be focusing on implicit biases, or those kind of hidden biases that unconsciously affect your decision-making, we can't pretend that explicit biases aren't a thing. They can pop up in insidious ways. Sometimes it's a new employee that wants to find evidence to support their boss's opinion. Sometimes it's someone who doesn't like or is just tired of arguing and wants to avoid findings that may be controversial. And it's the opposite. Sometimes it's someone who wants to stand out and focus on controversial findings. And other times it's really just a longtime employee that's been rewarded their whole career for cherry picking data to support management's predetermined position. Those cases are really more of an ethical issue than a skill issue and will not be the focus of this talk. But I feel like it'd be remiss if we didn't actually acknowledge that they exist. Having an analytic skill that other people don't have can give you great power. And kind of like Uncle Ben said in Spider-Man, with great power comes great responsibility. First bias we're going to talk about is survivorship bias. Hopefully it's one that you've heard before. And here's a great quote that I always enjoy when talking about this one is, if we have heard of history's great generals and inventors, it is simply because they took considerable risks along with thousands of others and happened to win. They were intelligent, courageous, noble, and had the highest possible obtainable culture in their day. But so did thousands of others who live in the musty footnotes of history if they're really discussed in history at all. So one of the classic examples of survivorship bias comes from the bombers in World War II, where they would arrive back and have bullet holes and markings on them where they'd been hit. And so they were analyzed to say, hey, these are where our planes are getting hit, and this is where we need to add additional armor protection to save our planes. When in reality, what was going on was those holes were showing where a plane could be hit and still make it home. Another example from the psychology space of non-cognitive of bias, survivorship bias, is really in some of the research around non-cognitive factors. One that comes to mind is grit. So one of the initial studies on grit involved military academy cadets, where they showed that grit was more important than IQ or SAT scores if they're predicting their ability to complete it. And one of the big kind of caveats there that wasn't necessarily mentioned when they were celebrating that finding was that these are people who have already made it into the U.S. military academy. Which for those that don't know is very highly selective and difficult to get into. So the idea there is you've already kind of controlled for so much variation in IQ that, yeah, it's possible that something else will come up and show to be more important than IQ. And from a more data science perspective, I see this as being a problem where there are some hidden variables that have a causal relationship with your model that are not accounted for within your modeling process. And if you look at survivorship bias in that way, there are really some more modern and really more insidious examples. So many models are being built to predict future human performance, whether it's models that are trained to hire employees or admit college students or identify high potential employees for leadership training. The problem could be that the historical data you have, you may have other societal variables that influenced previous success. So if historically society gave advantages to individuals based on gender, ethnicity, or race, those advantages may become unknowingly part of your model. I'd like to say that most data scientists wouldn't intentionally create a model that is racist or sexist. However, by training their model on data that may have come from a time where racism, sexism were commonplace, they may be inadvertently letting those ghosts of the past kind of continue to haunt the future. All right, well, that's probably a little bit further than I was intending in going on survivorship bias, but here we are. So when you for mitigation for survivorship bias, and if you kind of watch these slides, you might see some common themes coming up, is one of those: just thoroughly examine your data and your information sources. Kind of understand where the data is coming from and what may be impacting the data. And if you're looking for relationships in positive cases, another good thing is just examine negative cases for the same relationship. And one of those examples of Grit, when they were interviewing people who were very, very successful and determining what kind of things they were saying that were important to their success. It might be valuable to have also interviewed people who were not successful and see what kind of traits they had. And that may have helped kind of mitigate some of those problems that some of those psychological constructs are kind of dealing with now. That's a lot on survivorship bias. And I said I want to be quick, so let's go to the next ones. These I've grouped together: cluster illusion and false causality. They're not exactly the same thing, but they are, I feel they're related, and that they're kind of both tied to our brain's kind of pre-wired ability to see patterns and to start drawing causal inferences. That's the way that we're built. And for most human history, that's really been a feature and not a bug. However, for our cases, you have to be really careful that you don't kind of get caught up in those little inferences that come to you courtesy of your subconscious. So I know one of the fun examples of this, really more of a false causality, comes from the classic case of ice cream sales and murders in Chicago. And I guess I should have it on my slide somewhere if I'm going to talk about it. But they show that kind of very, very strong, over decades, this linear relationship between the number of murders and ice cream sales in Chicago. And you see that, and not, if you didn't think about it, they weren't labeled. If you didn't spend some time thinking about what those variables mean, you might say, hey, they seem really, really, really related. One may be causing the other. But when you realize that they're one's ice cream, the other one's murder, hopefully that people aren't going to start assuming that eating ice cream is causing murder. So I guess that could depend on how good the ice cream is, or maybe how fast you eat it. And once again, similar to survivorship bias, thoroughly examining data and information sources is really important there, kind of really understanding what you have coming in. The ice cream and murder example is an easy one because it's obvious that those things aren't related. If instead of ice cream and murder, it was, they were just labeled as X and Y, you might not know. It may not be as obvious to you that those two things really shouldn't be related, and there's probably some spurious correlation or possibly some other variable. In that case, it's heat or summertime that is causing that relationship. So really understanding the data sources for this one as well is kind of important. Also for that one, asking yourself what else could be causing these things would be equally important. So next one we'll hit is anchoring and the bandwagon effect. Similar to the last two, these are somewhat close to each other. I see conceptually similar, but definitely different biases. So anchoring is dangerous when you find what seems like a good, interesting lead early on, and you kind of focus too heavily on it instead of correctly kind of assessing all options. I know when lots of people talk about anchoring bias, they talk about how it's used in in sales practices, how if you go in and you're negotiating the price on a car or whatever, the salesperson is kind of trained to try to put out the first number, and that becomes the anchor that then you kind of both swing around later. But for this one, I really think anchoring is a lot of times early leads, and from the data science space is where anchoring becomes the larger problem. Bandwagon isn't something I see really with new techniques as they come out. And so similar to bandwagon, you have the novelty effect, which is technically a different cognitive bias, but they kind of play together quite a bit. And the novelty effect kind of causes or can cause temporary increase in performance of some new methodology or algorithm. That's really more due to the excitement than truly the efficacy of the algorithm. And how this happens is in practice, because it's novel, because it's new, because it's exciting, you might spend more time playing with it, more time kind of tweaking it or adjusting the hyperparameters, or you spend a little more time playing with your features to eke out a slightly better result than what could have been gotten from some low effort attempt using some other algorithm. And it's kind of the novelty effect that can cause that to happen, which a little later on in the talk, I'll talk about how you can kind of help weaponize the novelty effect to get you, to help you learn more, how you can kind of use that to your advantage. But we'll hit that a little bit later. Similar to the other one, so broken record there with thoroughly examine data and information sources. So that's just understand where it's coming from. Don't over rely on initial samples of performance. And when it comes to bandwagon effects, seek to understand why people are choosing the method. Try to do some due diligence in understanding how the method works and why it could be better than something else, rather than just kind of jumping in because it's the new rage. Next group are the sunk cost and hot hand fallacy. The old sunk cost fallacy. I have definitely succumbed to this one myself. Working in the people analytics space, natural language processing can take up a decent portion of my workload. And for those who haven't done a lot of natural language processing, especially when it comes to topic models on some kind of small to medium-sized data sets, you can spend a lot of time kind of tweaking and tuning your topic models, and sometimes way more time than they than they're worth. I've definitely found myself spending hours and hours trying to coax some better features out of a corpus when in reality I'm wasting my time. And if I were to take a break and sit back and kind of assess, I would be able to see that I'm wasting my time. Hot hand fallacy is hopefully one not as many people get into, but it's not so dissimilar from the previous slide we were talking about. And I'd extend this one to methodologies as well. Some people I've known people, and I've myself have been that person from time to time, especially with random forests. I love random forests, but just because you have a great success with support vector machine model doesn't mean you should start kind of relying on it for all the problems when a more appropriate method may be available. And I do have to remind myself that frequently with random forests, because I really like random forests. I don't know why. Maybe I learned them at a certain time in my life, and it's just kind of stuck with me, like the way I write 1997 on my checks. All right, so let's go ahead to the last one from the confirmation, the bias section. So confirmation bias. This is the last one, the last bias that I'll talk about explicitly, and likely the worst, most common and probably most damaging bias out there. I could talk for a week and probably not finish covering all the ways that confirmation bias has damaged science, education, and just the world in general. And there are two kind of well-argued explanations for why confirmation bias is so prevalent and so dangerous. So from the cognitive psych side of the house, they say that confirmation bias is due to your own internal self-developed model. We all have our models on how the world works and how different aspects of the world works. And accepting, or when you see information that's contradictory to your belief and that doesn't fit your model, would cause you to either adjust or have to rewrite your own belief system. which is difficult and costly. Therefore, it's easier sometimes to just ignore the things that would cause you to do so much work and just kind of blindly accept things that don't cause you to do more work. And the alternative explanation is really that your self-assessment of your own value is tied to the validity of your beliefs, which means that if your beliefs are wrong, then maybe you're less valuable. That threat causes your ego protection mechanisms to kind of kick in, which empowers you to try to find reasons why you're right and the new information is wrong. And so confirmation bias, I'm talking about a little bit here, but this is a big one. And hopefully in this space, as you guys consume information on data science and science in general, that you are being hit a lot with some of these biases that I'm talking about and have talked about. Biases are tricky in that you can't just know that they exist. Knowing that they're there doesn't make them go away. That's not a magic thing. I myself have to kind of remind myself about these biases from time to time, because they sneak in, and confirmation bias is definitely one of those. It's built into like the way that we're programmed to think, the way that we're designed to think. So you have to be constantly vigilant to not kind of succumb to this on a regular basis. And so the best way to do that is to try to treat all information the same, which means you either treat it all as being correct or all as being suspect. And obviously, if you're a data scientist, I'm hoping that you're going with the latter, that you treat all information as suspect. Another thing that you can do is play devil's advocate, which can be even better if you bring a friend, bring a peer, and kind of hash ideas out. Find somebody who is competent and you're comfortable with arguing. You're comfortable arguing with, and kind of hash through these things. Let's bring us to the end of the bias section. All right, so now we're past the bias portion. We're going to talk a little about Dunning-Kruger and its brother from another mother, imposter syndrome. But we'll start with Dunning-Kruger, and that's one of my fun quotes by David Dunning. There, one of the Dunning of the Dunning-Kruger effect. It's the first rule of Dunning-Kruger Club is that you don't know you're part of the Dunning-Kruger Club. So Dunning-Kruger effect has become, it's one of those psych things that 10 years ago, we all kind of knew about it in the psych space, but it was not a lot of other people outside there were very familiar with the term. It seems in the last 4 years, it has become more popular. But not necessarily. So while it's widely known, I don't really think it's widely understood, because it's not something that only happens to ignorant people. There aren't Dunning-Kruger people. We're all susceptible to the Dunning-Kruger effect. And it really has more to do with your level of knowledge within a domain than with your overall level of skills or academic achievement. For instance, I really enjoy hearing Neil deGrasse Tyson talk about astrophysics related items. I appreciate kind of the authoritative way he is able to talk about those subjects. However, it gives me a little pause when he uses that same authoritative tone when discussing sociological or psychological items. I mean, it may be that he truly does have a similar grasp on those concepts as he does on astrophysics, but I'm not sure he does. And due to the Dunning-Kruger effect, he may not be sure either. So Dunning-Kruger effect. So we'll describe the term, the slope here a little bit for those who may not have seen it. So it starts here. You have this. I don't know anything. I know that I don't know anything, and the concern here is I know a little bit, and my competence is kind of low, but my confidence is really high. So this is something for those who have been in academic environments. So this is, you see this kind of sometimes in freshmen. Or I guess if you're talking about K-12 schools, you'd see it in your seniors. But you see this kind of, I took an intro to philosophy, and now I am able to argue with the masters. That's kind of this stage here. And then what you find, you just kind of start to fall off when you start to realize how much there is that you don't know. And that's one way to kind of combat the Dunning-Kruger effect, is to think about something that you do know really well, and think about all the little caveats and different things that go into observations on that subject, all the variables that could be at play when predicting an outcome within that domain. and kind of dive into that. And when I say think about something that you know really well, so it's something that you know really well that you've spent a lot of time with, months, years, etc. And it doesn't have to necessarily be an academic domain. It could be fixing cars. It could be whatever. It's just something that you've kind of geeked out about and got really deep. And so now that you're thinking about that, so kind of take a look around and how much information is around you. So would you expect someone without your level of expertise to know all these little but kind of important intricacies? And from the outside, does it seem like this domain might be simple? Could somebody think it's simple and be totally wrong about how simple it is? And then I'd ask you to kind of think about those details and more of the volume of details, and then get out of your own little domain and think about something that you do not have years of experience with. Does it seem simple? Is it possible that could have just as many little minor but important details in that domain as the one that you are skilled in? And that's really one of my own personal ways of dealing with Dunning-Kruger is assume that nothing is as simple as it may seem on the surface, and everything has depth. And if I don't know that depth, or if I think that depth isn't there, it's probably because I don't know the depth. Kind of assess whether or not it's something that's worth diving into and getting to know the depth. But anyways, now that I've got you kind of questioning your own knowledge, it's kind of a good opportunity to jump over into imposter syndrome. So imposter syndrome, this is where you feel like a fraud. You think that you may be surrounded by people who know way more than you do. And in some cases, when you're just starting out on the topic and are among people that have been at it for years, it can be true. It's possible that within a domain, you could be surrounded by people that know more than you, especially if you're just starting out. But one thing to be careful of, if you just remember that last slide with the Dunning-Kruger curve, you have that peak where you know, but where you feel like you know, but you don't really know much at all. Imposter syndrome is dangerous when it shows up and you're at kind of the bottom of that curve, when you are or could be surrounded by people who seem very confident, and your lack of confidence makes you seem like you may be in over your head, when in reality you're surrounded by a bunch of people who are at the kind of ignorance peak of the Dunning-Kruger curve and just don't know it. So my advice really for dealing with the imposter syndrome is similar as it would be for dealing with the Dunning-Kruger curve. And it's just self-reflect, assess how much you know and how much you don't know, and worry less about what other people around you may know or may not know, unless their lack of knowledge may negatively affect you. And then the big one there to remember that, and I'll go back to Dunning-Kruger again, it's not I can't really stress that enough. It's not something that some people are susceptible to. The most surefire way to be susceptible to the Dunning-Kruger effect is by believing that it doesn't apply to you. It applies or could apply to all of us. So self-reflect, understand kind of where you are, how much you know, try to get as best as you can an objective understanding. Another way is to find a good mentor, somebody maybe within the domain that you're in that knows more than you that you can talk to, so you can kind of start to figure out where you are. So now that we've kind of hit biases in Dunning-Kruger, now we're going to get into improving your performance. How are we doing on time? 7:30. We're still doing good on time. All right. So flow. We're talking about flow, and not the girl from the Progressive commercials, but psychological flow. The child of Mihail Csikszentmihalyi. So what is flow? So flow is being in the zone. It's a merging of action and awareness, where you kind of lose your sense of self. You lose track of time. It doesn't feel like you're working or even really trying. So flow has been well studied recently in like the video game industry. They try to design their games to induce a flow state because it's addicting, and because it's people enjoy it. People enjoy being in it. And aside from that, flow was initially, the concept of it was initially, I guess, uncovered in relation to artists and kind of physical athletes and physical performers. And that was where it initially got its study on what is flow, where you'd have painters that were painting and they kind of would forget to eat or use the restroom for like a day, or in some cases multiple days, because you get in that state where you're just kind of creating and you just can like completely lose your sense of self. So flow, we're talking about some of the components and some of the benefits. Some of the benefits I've just hit. It's motivating. You want to get it. If you've been in flow, you want to do it again, which is why video games are particularly interested in getting people. They want those repeat customers, getting people in a flow state. Next, it's addicting. Similar to motivating, but kind of that next level. It really pushes you to want to do it again. Like you're getting, little internal dopamine hits that are encouraging you to do it again. Other thing that's really interesting with flow is the upward spiral of achievement, which I will talk a little bit on the next slide, because to get into a flow state requires a balance of challenge and skills, and the as you do a task more, or as you learn more, it requires a greater challenge for you to experience flow. So then you kind of need to get better, which is one of the reasons why video games are so apt and can be so good at that, is because they can start making things gradually harder as it gets on, because you need it to be harder in order to get that kind of same level of high, that same level of flow high. I don't think I like that. And benefits of flow in education. So that's kind of a newer domain, where they're showing that people can experience flow while learning. And then I'll go in a little bit in a second on how to do that, how to kind of get in a flow state while learning a task. Because when it comes down to it from a data science perspective, and this is why motivation, I believe, in this particular field is so key. So if you think of kind of learning your data science skill or your data science domain, some domains it's like you're climbing a mountain. So when I was one of my professors at Northwestern, when I was there in grad school, was talking about he told me getting a PhD was like eating 1,000 pounds of Jello. Or at least, I guess finishing your dissertation was like eating 1,000 pounds of Jello. Was each individual bite was not going to be that hard, but it's a lot of Jello, and you got to have some strategies in place to be able to eat all that Jello, because it's a task, and I don't see that as being that dissimilar from what we have to do in the data science space once you've kind of made the choice to get in here, other than it's not 1,000 pounds of Jello. It's never-ending Jello forever. It's you're not climbing Mount Everest, and when you reach the peak, you'll know everything that there is to know about data science, and you're done. It is an escalator that is going to constantly be moving. There's going to constantly be more, which is why I think it's critical to develop some of these strategies. And if you can get to the point where you can kind of work on the task and be able to enter into a flow state while you're learning these categories, or while you're learning these new strategies or topics, that can definitely help you to continue this kind of never-ending educational path that you kind of get into when you enter into the data science role. So next up, balancing challenge and skill. So this is one of the critical components of flow, of being able to experience flow, because the idea with it is that if the challenge is too difficult for your current skill level, you're going to experience anxiety and not be able to get into a flow state. And if the challenge is low, if your skill level's low, then you get into that state where here it's listed down there as apathy, where it's not challenging. There's no interest in doing it. Next up is boredom. The big one here to hit into is this upper right quadrant is flow, where both the challenge and the skill level kind of balance out. so that you're kind of at that optimum. And so it's difficult to determine that for yourself. One way is to possibly schedule your learning so that it is more of a stepstone way. Don't, if you're not comfortable with something like linear algebra or multivariate calculus, you might not want to jump headfirst into some of the more complex algorithms that are out there without kind of knowing that first. And so it's good to go back and start that. For some of those, and that's stepstone away will help you be able to kind of manage that flow, that flow state, the ability to get into flow. Which, speaking of getting into flow, let's hit some of the specific things. So one I was just talking about is really more of the incremental improvement portion. So too hard, too fast, and you can't flow. Ideally with flow, you do need to push through the beginning. There's evidence of a relationship between grit and flow. Grit is a passion and perseverance for long-term goals. The theory is that grit gives people that initial kick they need to build the skill to get into a flow state. And the intrinsically motivating aspect of flow then becomes the rewards that allow people to persevere. Next up is action and performance based. One thing about getting into a flow state is as much as you can do it. Sitting and listening to a lecture or a talk it's not a great way to learn. At least not a great way to enter flow and learn. It's like to get into flow state, you need to be doing something. So sometimes instead of, say, you have a certain block of time during the day or during the week that you can do kind of data science educational activities, instead of spending 3 hours on lectures, maybe spend 30 minutes on lectures and the other 2.5 hours trying out something that you learned in those lectures. But actually doing something, getting in there, getting your hands in and doing it will increase the likelihood that you'll be able to get into a flow state. Another one big for flow is decreasing your stress. I know we talked about, if the challenge is too hard, you get stressed, you don't do it. I'm talking about different. This is just your overall stress level. So there's been a fun study done in Germany where they injected people with cortisol. So they had people that they had tested previously and were able to enter into a flow state, and then injected them with cortisol, or the stress hormone, the stress drug, and they weren't able to get into flow once they were injected with after they were injected with cortisol. Doing the same activity, they were able to experience flow previously. So stress is a known inhibitor. So decrease your stress. There's lots of different ways to do that: exercise, other mindfulness activities, etc. Maybe stop watching the election coverage or Twitter or shut down Facebook, whatever it takes. Next one is removing distractions. So set up a space to decrease distractions so you can concentrate on your task. It's not really necessary once you get into flow. Once you're in flow, distractions can come up and you can kind of just ignore them once you're in a flow state. But distractions can definitely inhibit you from being able to get into that flow state. And when I say distractions, so we typically, when you think of distractions, you think of it as kind of a static thing. So I'm going to remove there's distractions from my person, my phone, my whatever. But I will say also removing distractions from not just your physical space, but your temporal space as well. So kind of the time, dedicating some time that you're going to be there, and you can communicate to your significant other or roommate or whoever may interrupt you that you're going to be doing something, and you would like to not be bothered unless it's an absolute emergency during that time. So another way to move distractions. Another one here that seems odd is get a hobby. Get a flow-inducing hobby: music, sports, running, and even playing video games. Gives your mind kind of a taste of flow and what it feels like. And like I said, flow is addicting. And if you get to the point where you can enter a flow state and you kind of know what it feels like, research has shown that you're more likely to be able to experience flow in other activities. So if you get into running or biking or some activity that you feel like you can just kind of get in the zone and just kind of lose track of time and go through it. Doing that can help you be able to get in flow in education. Next one on here is the meditate. So meditate should be, I guess, possibly a little more obvious. There's a lot of focus on mindfulness meditation as a way to kind of engage in a flow state. And there's quite a few different things online to check on that. I am and always was more on the research side of psychology, not on the meditation side. So while I'm aware of it from a user standpoint, from a practical or from a clinical standpoint, not my area of expertise, but for a lot of people, meditation is a really good way for them to get into a flow state. All right, so now here, there's lots of parts of the presentation I went through here that sometimes when I talk about this, they'd be a little more interactive. I'm gonna check and see here if there's, I've been seeing some little buzzing on the side of my screen and see if those are questions that are coming in. All right, so
if you open if you open the Q&A section, there should be 2 already so far.
Yes, I'm pulling up here. And anybody else want to hit me up on there? I am definitely at the point where I'm up for talking and expanding. So I see the first one there. The cluster illusion and false causality mean exactly the same. No, not really. They are. So cluster illusion is where you're seeing just a relationship or a grouping that may not actually be there, where false causality is you're seeing a specific causal relationship that might be there. So I think from a cognitive perspective, there's probably the same thing that's driving both of them. And it's that your brain's natural tendency to see and to want to see patterns. But as they've been defined in the literature, there are slight differences, but the differences may be mostly semantic. Next up from Luis, they find myself oscillating between Dunning-Kruger effect and the imposter syndrome. Confidence, self-doubt. So best way to ground your thoughts, move from one of those to constructive actions. Well, I covered that a little bit on there, and it's really self-reflection. And it's not something that you're just going to be done about. So it's gonna happen. You're gonna bounce between, just like the biases. There's not something, I wish that there was something, and maybe there is, and it just hasn't been discovered yet, that you could do, and then all of a sudden you've solved it forever. You've solved the Dunning-Kruger effect for yourself, or imposter syndrome, or you've solved these biases forever. You've taken this one green pill and now you're good. Unfortunately, that's kind of not the case. But self-reflection is a big one for the dealing with Dunning-Kruger and the imposter syndrome. So imposter syndrome is especially people who are learning, and I don't know where you are at in your studies, or kind of in your process, or where you're going, Louis or Luis, but sometimes imposter syndrome in the beginning is good. Sometimes it's a sign that you've made it over that initial hump, and that you're getting somewhere. But one of the things with imposter syndrome you really want to take stock of is if there are people around you that are making you feel like you don't know things because of how they're talking. You want to kind of evaluate where you are and who you're around, and if that feeling is appropriate. And so I would say one of my biggest things with imposter syndrome is the first time I spoke at an event a few years ago. I share the stage with Cassie Kurskoff, who is, I know, on LinkedIn quite a bit, and a fantastic speaker and chief decision scientist at Google. And this was my first speaking event, and I followed her. And oh man, was I nervous, and was I kind of blindsided with how good and how polished she is, and even if, and that's not me, I'm not that polished, and it took me a while to kind of realize that different people have different styles, and my style was never going to be the same as hers. She comes off like it's, I don't know whether she does memorize what she says before she says it, or whether she just speaks in really good complete sentences all the time. Anyway, I don't know. But either way, I've kind of, it took me a little while, a couple of years to come to grips with that's not me. I speak in a mixture of sentence fragments and run-ons, and that's what's going to happen, because I don't have the I don't have a good mind for memorization. I would not have made a good actor memorizing lines, but my natural way of speaking is just going to be sentence fragments and run-ons. It's happening. All right, so Dave, flow balance between skill level and challenge. Why is flow in the upper right challenge a skill diagram? That's a great call out. So there's two different diagrams for flow. One of them is one I just showed you, which is kind of a newer one where it's showing that domain, and I dislike it. There's another one that does show it as that balance between skill and challenge. The other one though is I did not. You have to get a it's free, but you do have to apply for a license and state each time you're going to display it or use it. And I did not for that diagram for this particular presentation, so I couldn't use it. And the one I did use is the public domain, the newer one that is, I don't remember who wrote it, I think that may be Nakamura instead of Csikszentmihalyi, but it's the newer one, public domain. And I really threw it in there as kind of a placeholder while I didn't have the other one, but that's a good call out, Dave. All right, so Nicholas, that is my middle child's name. So currently transitioning from biomedical engineering to data science. So interested in how I transitioned from psychology. I can talk about that, I guess, a little bit. It was, so it's been my experience that going from engineering to data science, you're probably going to have a lot easier experience than I had from psychology. Although I could be wrong about that. I could be that I don't know, because I could be on the other side of the downside of the Dunning-Kruger curve as far as that question goes. But it's been my experience, at least in my role and the other ones I've met, there's a lot of people in the data science space that come from engineering background and kind of applied. And there is, going from psychology, I guess the biggest hurdle I had to overcome was some of the pseudoscience aspects of psychology. So psychology is one word, but it's incredibly wide, wide domain with some really kind of questionable things in certain areas and corners of psychology that as kind of a domain that they need to work through. So one of the reasons why I talk on flow and why I do a lot of talk on flow is so there's a lot of different psychological theories that have questionable scientific validity. I could say it, I think, as a psych PhD, I feel like I'm allowed to say that and not be branded a heretic. But I like flow because flow is one of those that you can see it in an fMRI. You can, stick somebody in a machine, objectively observe a flow state occurring, which there are other aspects of psychology that you can't really, you can't do that. And they're not to say that they're not true. There are definitely some tiers. One I can think of, a great example is self-determination theory. So it's been around since probably before most of the people on this call were born, including myself. And it's been challenged over and over and over and over, and it keeps persisting. It keeps winning. And self-determination theory is that motivational theory that divides, motivation types into intrinsic and extrinsic motivation, and the intrinsic is better typically than extrinsic or controlled motivation. And it also has the sub-theory of basic psychological needs, and that people need to feel a sense of autonomy, competence, and relatedness in order to feel good or have, you know, well-being and kind of a positive self-image, and that you need those three, and you can possibly deal with minor issues with one by overcompensating with others where possible. But anyways, I'm getting past what your actual question is, and I apologize about that. But going from engineering to data science, one thing is you'll definitely have better math. A lot of psychology programs don't do well with math. I had the benefit of starting in computer science. That kind of got me there, and then going to psychology later. And I wound up going from somewhat from analytics to psychology and then back again, was because I kept, I guess my parents would tell you, I started asking the question why when I was like 5 years old, and I continue to ask the question why. And when I was initially doing computer science, then going into analytics, I kept asking myself, you know, so I'm basically predicting behaviors, and why are they doing this? Why is this customer doing what they're doing? And why is this employee doing what they're doing? And in the analytics space, I didn't find a lot of interest in the why, or a lot of answers around the why. So I thought, hey, maybe psychology is going to give me those answers. And so then I transitioned over and then went deep into psychology, and that's where I wound up actually going through to the graduate and PhD side, was in the psychology vein before I came back. And psychology didn't really answer a lot of the whys either. It definitely gave some better leads, but it doesn't answer all the whys. But it does have some theories to potentially answer the whys. So I don't regret it. But yeah, the math thing should be okay. So the other part for data science, for transitioning from any field into data science, is to really focus on the areas of the advantage that your previous domain give you within it. So from psychology, as I moved into more of a data science role, but prior to that, I was really more of an analyst, a data analyst, before going through my little psych rabbit hole. But then coming back and seeing how that previous experience gives me certain advantages within the data science phase. From psychology, it really comes down to, it does help me with some of the whys. And I would think there may be similar things from the biomedical engineering side, that there are some, having kind of that domain knowledge gives you some advantages and sometimes the advantages can be simple or tactical advantages. So like from the psych side, particularly in psychometrics, we become really good at dealing with ordinal data and things you can and can't do with kind of that ordinal data, the human gathered psychometric data. That is not just applicable there, but it's applicable outside of psychology in other areas of data science. And I guess for psychology, Cambridge Analytica helps that too, when you have psychometrics, the combination of psychometrics and deep DS practices, creating some things that kind of reshape the world to some extent, and probably not in a positive way. And next, Nick. All right, so you specified my job search journey. So my job search journey was probably not a good one for that, because mine was, I've been with the same company as my primary job for 15 years. So I would feel remiss to share a lot of that. Even within the organization, I have made movements within, and then I have also done work, as long as when I do work outside, as long as it's not for a direct competitor, we're allowed to do that where I work. So for instance, I've done work for like TEA, the Texas Education Administration. And like they mentioned when they introduced me, I lead a STEM nonprofit, a STEM education nonprofit. So I do some work outside, but it's that's mostly just kind of soft volunteer work. So what and where is the other challenge for the skill diagram that I mentioned? If you Google challenge skill balance, you'll probably find it. It's black and white. It shows a line of challenge and skill. It probably shows, I believe, the above and below are stressed and bored, or the above and below that line. And it'd be by Csikszentmihalyi. is who the I guess the author, and that's that awful name. I can't spell it. CSIK Seasick Csikszentmihalyi. Do I have it on here somewhere? There we go. Csikszentmihalyi. And a fun quote from him: "Of all the virtues we can learn, no trait is more useful, more essential for survival, and more likely to improve the quality of life than the ability to transform adversity into an enjoyable challenge." All right, any other questions?
Yeah, there's actually one in the Zoom chat. You have to scroll with it, but I'll just read it to you if you want.
Sure.
Are these things you mentioned in the how to get into a flow state slide proven from some sort of analysis? As a data scientist, did you get work into any such analysis?
Oh, sorry, I missed, what was the last bit?
Oh, as a data scientist, did you work on any such analysis?
Yes. So we have so for getting in the flow state, so I've worked on flow state and call center employees as a data scientist, where we do, so one of the hallmarks from so diary study is the term. They're still called diary studies or experience sampling method, ESM studies, which is where you do little interruptions in people's day to ask them how they're doing. So unfortunately, in the corporate space, we're not hooking people up to fMRI machines to confirm, but we do have some valid instruments that what we do is you interrupt their day, you interrupt their time. The old way, the old classic method was with a pager. You'd have a pager that would go off at a random time, and when the pager would go off, they're supposed to pull out their little questionnaire and fill out the 2 or 3 questions, and that's how the diary study method works. We've gotten a little more elegant now, where we're able to do a screen pop, where you kind of the little survey takes over your screen and you fill it out. And the idea is to kind of interrupt you and then ask you questions to assess whether or not you were in a flow state, and that happens with the people under study kind of randomly to see it. So that's research we've done detecting flow state. For the other bits, the other part of the question for strategy to get into it, the only one that's really well studied, or the two that are well studied from a scientific standpoint, I would say would be the do something and decrease stress portions. Those have significant study, and when I say they well studied, I'm talking ones where we've actually done like true fMRI studies where they can see conclusively that somebody was in a flow state. They weren't relying solely on kind of a self-report. However, all the other ones have been studied using self-report questionnaires, which are not necessarily awful. They're just not the best things that can be done. But they are quite a bit. There's been quite a bit done on getting into a flow state. It became really popular. I don't know how many years ago, 8 years ago, 9 years ago. Once psych departments, well, once the cost of time and if an fMRI machine was low enough that psych departments were able to get access to those machines and started sitting people in them, flow became really, really popular because you could see it. And there's a lot of other things in psychology that you can't stick somebody in a machine and see it happening. So it became really neat. And so there was quite a bit of research in that range. And I don't really I'm not prepped on here to go over the individual studies, but I encourage you to hit up Google, preferably Google Scholar. You can kind of see some. A lot of them are old enough that you should be able to get access to them without them being behind paywalls. All right, why is getting a hobby important for getting flow state? Yeah, it's a fun one. So so I guess not just a hobby, a flow-inducing hobby. So if you are somebody who has not been in flow, the idea there that's been studied is that if you find that if you kind of break that barrier and get into a flow state in one domain, even if it's just in cycling or boxing or race car driving or whatever this hobby is. If you're able to get into a flow state in that hobby, it increases the likelihood that you would be able to get into a flow state in other domains. Because the idea is your brain is truly operates slightly differently when you're in a flow state. Typically, it's evidenced by a decrease in activity in your prefrontal cortex, with its that idea that your conscious mind, or your self-conscious isn't really driving it as much, in increased activity and other areas associated with whatever the task is you're in it. Another fun hobby for flow, if you're just kind of up there for hobbies, is there was fun experiments done, I think 2012, 2013, on freestyle rappers. That was fun. Is they stuck them in a fMRI machines and had them freestyle rap, because the question was, how can some of these individuals with maybe below average scores on tests of like verbal acuity or RIQ test, people that from a psychometric measurement standpoint should not be very good at coming up with kind of complex word associations and rhyming schemes. However, when they're doing freestyle rapping, the little things they draw are just brilliant. How is that happening? And so those were ones that the experiments, I think they were at University of Chicago. They stuck them in fMRI machines and saw that in one of the earlier ways that they saw the flow state, they saw it kind of light up. It's because they weren't the area of your brain that would typically be associated with taking those cognitive tests of ability is not the area that they were using when they were doing their freestyle rapping, which are fun. Those are fun studies to read on. All right, signpost if you're in a flow state. So if you've been in flow, one of the easiest to spot is temporal distortion, which is a fancy way of saying that you lose track of time. You get absorbed in it. You turn around and you realize that an hour has gone by and it feels like no time has gone by. So temporal distortion is probably the easiest. And I would say temporal distortion plus a positive feeling, because there's another thing that causes temporal distortion, and that's hyperfocus. And hyperfocus is currently being argued as being different than being in a flow state. Jury's still out on whether or not it's truly different. So hyperfocus is something that's typically more associated with people that have like ADD. And so we become so focused on something that you lose, that you don't notice anything else around you and time just flies. The flow camps say that hyperfocus and flow are different because flow gives you a good feeling afterwards, and hyperfocus can a lot of times give you a bad feeling afterwards. And I honestly don't know, because I haven't studied it, and I don't believe the research is out there to say definitively that they are different. But I would say that's the biggest signpost, is that you lose track of time. And if you lose track of time and you feel good about what you've been doing, then I would say it's flow. If you lose track of time and you feel bad about what happened because, oh my God, I just wasted an hour of my life, then it may not be flow, or it may be flow. I don't know. That's the jury is still out, and it's a kind of highly contentious thing. Unfortunately, I don't know if that is going to be answered before Chicks Hit Me High leaves us.
All right. If there's no more questions, I think we can just wrap this up. Thank you so much, Wes, for coming. And thank you everyone else for attending these talks. We hold these talks to keep people learning and to keep them furthering their learning. So everyone who has done that, congratulations. Thank you for coming. If you haven't already, please make sure to subscribe to our YouTube channel. Comment what you thought about today's meetup or what you think about our online Zoom format. Also, please join us for our next scheduled meetup on October 14th for a workshop on data analysis with Python. Thanks, everyone, and have a good night.